This video covers Trig Notes 2.4 and Pre-Calc Notes 5.4. We're going to be looking at the sum and difference formulas on our formula sheet. So you're going to want to have that out. You'll notice that I've taken from the formula sheet the sum and difference formulas and I've inserted them onto your notes here. This is really the only part of the formula sheet we're going to be dealing with. And what the sum and difference formulas will do, it will allow us to find the exact values of sines, cosines, and tangents that are not on our unit circle. So in the past, if I said find the exact value of the sine of 105 degrees, you go to your unit circle, you look at that, and it was always an angle that was on the unit circle. Well, 105 is not on the unit circle. So what we're going to do is we're going to come up with two angles that either add together to be 105 or multiply to be, or subtract to be 105 that are on the unit circle. And if I asked you to just type this into your calculator, well, when you type it into your calculator, you're going to get a decimal, which I'd have to round, so that's not an exact value. So how do I come up with the exact value? That's where the formula comes into play. So if I want you to find the sine of 105, what I want you to do is look at your unit circle and come up with two angles that add or subtract to be 105. So right away I'm thinking 60 plus 45, because I know both of those angles are on my unit circle. So I'm going to, instead of saying the sine of 105, I'm going to say the sine of 60 plus 45 degrees. Now if I add that up, I still get 105. So since I'm using the plus formula, I'm going to use this top form. I'm going to use sine, the plus, so when I come over here to use the actual formula part of it, I have to use the top value, which is the plus sign here. So I'm going to set it up like this. If this is sine of 60 plus 45, what that means is that my u value is 60 and my v is 45. And now I just plug in 60 and 45 for these u's and v's. So this would be equal to the sine of u, sorry, not plus, times the cosine of v. So that's how I got that right here. Then I have to use the plus. Let me erase that so that you can see that there was a plus there. I'm using the top one. Then the cosine of u, which is 60, sine of v, which is 45. And this is where we want to then go and get these values from our unit circle. So from our unit circle, if I'm looking at the sine of 60 degrees, I'm noticing that it's the square root of 3 over 2. I'm going to times that by 45, which is the square root of 2 over 2. I'm looking at the unit circle. The cosine of 60 is 1/2. And I'm going to times that by the sine of 45, square root of 2 over 2. So to multiply these together, I need to multiply the numerators together and then the denominators together. So I end up with square root of 6 over 4 plus square root of 2 over 4. I can add those together because they both have a denominator of 4, which would be square root of 6 plus square root of 2 over 4. So that's what I'm saying my answer is. Now if I'm not sure if I'm right, get out your calculator and plug this in. If you type in the square root of 6 plus the square root of 2, get an answer and then divide that by 4, you should get this same exact decimal, 0.9659, that we got earlier when we just typed the sine of 105 in. What I like about this section is that you can always check your answers by taking the calculator and figuring out what the actual sign is in terms of a decimal, taking your answer and figuring out what your decimal version of your answer is, and then if they match up, you know you did it right. The other thing that I'm going to say is that your answers might not always match up with what the book says, especially when we get to the tangent portion of it. That's okay if they don't match up. That's why I'm showing you the method to check with your calculator so you know if you're doing it correctly. Sometimes the book takes it a little bit further than what we're going to do, so if your answers aren't necessarily matching up, use the calculator test method. Plug it in the calculator. If you're getting the same decimal, then you know that these answers have to be correct. Alright, let's work with the tangent now. The tangent of 195 degrees. Let's first just see what it is as a decimal in my calculator. It is going to be 0.2679. I'm going to figure that out so that when I go to check at the end, I can see if I get that same decimal equivalence. If I want the exact value, I want to think of two angles that either add or subtract to be 195. So I'm looking at my unit circle, and I'm going to use the subtraction one. I'm going to do 225, and I'm going to subtract 30 from that because that's going to give me 195. Now the tangent formula can be a little bit tricky here, because you see that there's actually 4 different spots you got to plug the tangent in. And tangent isn't necessarily something that is on our unit circle, it's something we have to actually calculate from the values on our unit circle. So this is u, this is going to be v, so the formula says take the tangent of u, and then because we're using the minus sign, that's the bottom one, we're going to use the minus in the numerator, because that's the bottom one. Tangent of v, which is 30, we're going to divide that by 1. Again, we use the bottom sign here, so the bottom sign in this one is a plus. It's not going to be the minus because we use the minus. It's whatever the top or the bottom sign is. In this case, it's a plus. Tangent of u, 225, times the tangent of 30. So if I go to my unit circle, I'm trying to find the tangent of 225. Here's what I know the tangent is. It's the sine divided by the cosine. So at 225, what I'm noticing is that the sine is negative square root of 2 over 2, and the cosine is negative square root of 2 over 2. So that's how I would calculate the tangent of 225. So from that I'm going to subtract the tangent of 30. Well, at 30 degrees, the sine is 1/2, and the cosine is square root of 3 over 2. Now what I'm going to do is I'm going to simplify this in my numerator before I plug this information down into my denominator, because I have to do the same thing again. I have to figure out what 1 plus the tangent of 225 is. Well, what I know is that when I divide this out, I'm going to get a 1. When I divide this out, to divide it out, I get rid of this by multiplying by the reciprocal, 2 over the square root of 3. So it ends up becoming 1 for here minus 1 over the square root of 3. And down here, if we go back to the formula, it was 1, so that's how I got the 1. Tangent of 225 when I divided this out is 1. Tangent of 30, we said, is 1 over the square root of 3. When I multiply this out, I end up with 1 plus, multiply here, 1 square root of 3. That's not a minus there. Okay, so again, what I recommend is you figure out what the tangent of 225 and 30 is in the numerator, and then you just plug those values into the denominator. Now here's where it gets a little bit confusing. I've got a fraction inside of a fraction. So what I want to do here is I want to eliminate the fraction. And here's how I'm going to do that. In the numerator here, the denominator of this fraction in this numerator is the square root of 3. So if I can take this entire problem here and times it by the square root of 3, when I distribute that in, what happens, and I'm going to do that all the way over here, is I get the square root of 3 minus, these cancel out, 1. Okay? Let's apply that same concept to this denominator. In the denominator here, the denominator of this fraction is the square root of 3. So let's multiply everything by the square root of 3. And you're going to get square root of 3 plus 1. Now, the whole purpose of me doing this, of multiplying by this square root of 3, is I eliminated the fraction inside of the fraction. Notice I don't have a fraction inside of a fraction anymore. Okay? And that's going to be key, that you want. That's the whole reason we want to multiply through by that square root of 3, is so that I don't have that irrational number in terms of the denominator having a square root in it. Now I have to rationalize. So if I rationalize, the process says, take a look at your denominator. To get that square root of 3 out of it, you have to multiply it by the conjugate, which is the square root of 3 minus 1. So you just change the sign here, and what you do to the numerator, you have to do to the denominator. And so what you really have now is two FOIL problems. So when we multiply these together, we get 3 minus square root of 3 minus square root of 3 plus 1. FOIL the denominator, you get 3 minus square root of 3 plus square root of 3 minus 1. Now the whole rationalizing process, the reason we do that is so that the square root of 3's end up canceling out, and I get a 2 in the denominator. In the numerator, I might not necessarily get anything to cancel out, and I don't in this problem, but 3 plus 1 is 2, and negative square root of 3 minus square root of 3 makes negative 2 square roots of 3. Last thing I can do here, actually I just noticed I made a mistake, it's 3 plus 1, not 3 minus 1. This should have been a 4. So again, it's this 3 plus this 1 to get 4. Last thing I can do here is I can actually go through and divide everything by 2. So divide this by 2, divide this by 2. I get 2 minus the square root of 3. Now remember at the very beginning of this problem we went through and we said that it equals this decimal. Well, let's type 2 minus the square root of 3 in our calculator. 2 minus the square root of 3 gives me 0.2679, same decimal, so I know my answer is correct. Hardest part about this problem is, I think right when you get to this step here, you've got to eliminate the fraction by multiplying by whatever that denominator is. Most of the time, when you're doing the tangent values, it's going to be that square root of 3. Then I think the second hardest part is right here when you have to rationalize. You look at what the denominator is and you multiply by the conjugate. Remember, the conjugate is just the opposite sign of this. So if this is square root of 3 plus 1, you multiply by square root of 3 minus 1. Okay, it's not because that's what the numerator is. It's you multiply by the opposite sign in the middle of this binomial here. And then you FOIL and reduce. Again, take the time to plug this into the calculator, verify that you're getting the same decimal. That way you know that that answer is correct. Now sometimes we can use the sum and difference formulas to help us verify an identity. So if it says verify an identity, what I want to do is show that this left-hand side equals a cosine. So I'm not going to move anything over, I'm just going to use the difference formula, because there's a minus there, and it's the sign. So I'm going to use the difference formula when I know that it is u is 90 and v is theta. So if I use the difference formula, I've already listed the formula over here, it's going to be the sine of 90 cosine of theta. Then because it's the minus sign, which is the bottom, I use a minus cosine of 90 sine of theta. So if we go to our unit circle, the sine of 90 is 1. So we have 1 times the cosine of theta minus the cosine of 90 is 0 times the sine of theta. And remember, keep in mind that our end goal is we want to get this to reduce down to a cosine. Well, 0 sine of theta is nothing, and 1 times the cosine of theta is just the cosine of theta. And so we're able to end up to get it to be the cosine of theta. So sometimes we can use these identities to help us verify something. In this case, we were trying to verify an identity that is actually on our formula sheet. Remember that this is one of the cofunction identities from earlier on. Didn't spell identities right. Let's try this again. I got one too many I's in there. There we go. That's an N. That's just making it worse. Probably should have stopped while I was ahead. This is one of the cofunction identities. Apologize for that. I had a hard time with that spelling there. And so again, we can use that to help us with the whole process of verifying. That's how we're able to get this to equal a cosine. So we don't always just use this to find the exact value of a trig function. Sometimes we use it to verify, and sometimes we'll use it to solve equations, which is what we're going to do in part 2 of the video.